by Tirupati station, but it will not be observed by the other stations. Oh, sorry, one second. I'm really sorry. Yeah, so it will not be observed by the IIT Madras or the third station, right? So in that case, we'll have a confirmation that it is not a meteor, because if it is a meteor, then it should have been observed at all the three stations. So that's how the triangulation works. So now moving ahead. So how exactly the CAMS algorithm works? So CAMS uses a machine learning algorithm. So let's take an example of a dog. So we all have either owned a dog or seen a dog, right? So whenever if we try to feed a dog, he'll have a salivation because he will want to eat the food, right? So I'm taking one case. So I have a dog and I'm feeding him. So every time I'm feeding him, he wants to eat the food because he likes the food. Okay, so that's the case one. In case two, I have a dog and I'm ringing a bell in front of him. But now he doesn't know what the ringing of bell means. So I'll have no response from him. When feeding him, I'll have a response from him, which is he wanting to eat. While ringing the bell, I will have a response to him. Now, every time I'm feeding him, if I ring a bell, then and I'll repeat that for a few times. Let's say for 10, 20 times. Okay, for 20 times. And at 21st time, what I'll do is that for 20 times, I have rung the bell every time I'm feeding him. So at the 21st time, I only rang the bell. But then, as in the earlier 20 times, the dog has learned that every time the bell is ringing, I'm getting food. At the 21st time, if I just ring the bell, he'll understand that he's gonna get some food. So then he'll have he'll want to have the food. He'll have salivation. So in the 20 earlier times, I'm teaching the dog that ringing the bell means wanting to have food. So that's exactly how ML algorithm works. So I'm teaching my computer that this something means this. So for example, when we teach child, right? When we have a child and we're teaching the child, right, what dog is, what a cycle is, what a car is. So if I tell them like 10 times that this is a dog, this is cycle, this is car, 11 times he'll understand that he'll point it out that this is a dog, this is cycle, this is car. So in similar case, one example for AI algorithm I'm taking is the autopilot algorithm. So like in Tesla. So Tesla has the self-driving cars, right? So we need not drive them; they will drive themselves. So this is like how do they work? So like this one example is classifying the cars in front of the car, right? So in this case, you can know that this is like by seeing that this is SUV, this is passenger car, this is sports car, this is police car, because we know we have learned like for my case last 20, 21 years what each car looks like, right? In the same case, I'm teaching my AI algorithm of which is used by the car that this specific car of this size, this shape, and like all the other parameters is SUV, and the second parameters are for passenger car, and so and so. So every time now my algorithm knows that these parameters belong to this specific car. These parameters belong to this type of car. So every time when it observes, every time it records or captures the images of the car in front, based on the parameters of the car, the algorithm will know that which car it is. So that's how the ML algorithm works. So a similar algorithm has been used to classify the meteors. So how does it work? So for example, in this case, this image here is an image taken by one of the CAMS networks of a satellite, while this image is of a plane taken by a satellite. So taken by a CAMS network. So here in this image, this picture, this is an image of a bird. So these are the general objects which are observed during night sky, other than which are moving. So meteors, and then they are the meteors which are captured. So now the thing is that we know that how a meteor looks like because we have seen them, most of us. we have seen the meteors. So now we know how a meteor looks like. But then the issue is that the data collected by CAMs every night is in thousands of images. So for one single station, so one network consists of 3 stations, and there are about 600. There are about 20 stations all over the globe. So in that case, the 20 multiplied by 360. So each station has about 1,000. So there are about 60,000 images per night. So and every night there are more 60,000 images are coming. So in that case, classifying these images by a human is a tedious job. It is a very nearly impossible job. And if there is a backlog in the first day, then that is added to the second day. So now for the second day, I'll have to classify 60,000 plus the backlog images. And as a human, as I work more and more, I get tired more and more. And when I get more and more tired, that means that the possibility of me making an error increases. So in the beginning, let's say in the beginning, I may classify all the images properly. But as I get more and more tired, I may classify this as a meteor, and I may classify this as a plane. So this kind of errors can happen. So to reduce this error and to reduce this human work, the algorithm has been written. So here what we have done is that for the first 1 year of CAMS was working, so we have about 1 year of data which was classified by humans. So that 1 year of data, there we have the data as which are the meteor showers and which are non-meteors. So using that meteor and non-meteor shower data, the CAMS algorithm has been taught. So based on that, the for the first time, the CAMS algorithm was used. So after that 1 year, there was an additional data which was gathered. So now what CAMS does is that at the end of each year, the new additional data classified and captured, that data is again added to the earlier learning set which we had, and again the algorithm runs on this new data. So what it does is that it makes the algorithm more and more accurate as there is more and more data coming, and the algorithm is learning on more and more data each and every year. So for CAMS, we are using the parallel by LSTM. So parallel by LSTM means the bidirectional LSTM algorithm. So here in the bidirectional LSTM algorithm, we are taking the input is first taken, one of the LSTMs takes input in forward direction, while the second LSTM takes input in the backward direction. So these two forward and backward direction inputs, that they effectively increase the amount of information which is available to the network, and that itself improves the content available to the network, and that makes the algorithm more precise. So here in this case, these are the 4 models which have been used for meteor shower classification. And as you can see, the precision, which is the true positive upon these true positive plus false positive. So in this case, true positive will mean that out of the classified images by the algorithm as meteors, which all are the meteors, that will be true positive, and the false positive will be out of the classified image as meteors, what all are not actually meteors. So the precision and the recall is the again true positive upon the addition of true positive as false negative. So here false negative is that out of the total classified images of meteors, which are not actually meteors. So that is the false negative. So these precision and recall values, which are for parallel by LSTM, are observed to be about 97 and 98% respectively. So comparing these four models, you can see that the parallel by LSTM seems to be working. Seems to be the most precise model. So what CAMS bringing CAMS India is bringing is that the mentorship from Fortune 500 companies. For example, CAMS is in collaboration with SpaceML and FDL and NASA. So there is a mentorship from these kind of institutes, organization, companies which are available, and because of that, a student, or let's say a student who is working on camps, gets to work with the experts in this field all around the world. And camps does not bring opportunities only for astronomy and astrophysics, but as you can see, as it works on AI, there's a huge opportunity in computer science and AI careers, and there is also a huge opportunity in geology, as some of the meteors are reaching the Earth, and and these trajectories can also be calculated using CAMS data, and then the data is available to the public. So as CAMS is citizen science project, all the raw data collected by CAMS is available to public. So one of the BSMS fifth year students of IISc Tirupati, named Sayadri Krishna. So he had done an internship with SpaceML, working on the algorithm of CAMS and the website of CAMS, where all the data is made available. And his experience, he has written about his experience on a blog which is published on Medium. So I have been leading the CAMS for past about 18 months, but this work, these 18 months went perfect. We faced a huge amount of delays and challenges. So one of the major challenges was the challenges faced because of the current pandemic. So because of the pandemic situation, all of us, nearly all the time, all the team was working from home, and purchasing and because of that, the approval of funding and the approval of purchasing, that caused a huge amount of delays. And the second challenge was that the actual cost of the instruments which we received based on the quotations was higher than the funds that was approved to the individual institutes. And another challenge was that we already have two stations, which is IISc Tirupati and IIT Madras. But as I mentioned earlier, because of the triangulation, we need a third station, and getting a third station was an issue. So as solutions, there was no other solution for the pandemic, as we had to work online. But we made the most of it, and we nearly have all the instruments purchased. So like for the last few instruments, we have submitted the purchase order and will be receiving soon. And for the funding issue, what we did is that, as I mentioned earlier, that we had a crowdfunding campaign by CAMS AT. So from the instruments were purchased and shipped by SETI Institute, and they were received about a month earlier at IISc Tirupati. And the remaining half the instruments were purchased by the individual institute funds. And currently we have proposed IIIT Sri City as the third station. And right now we have ongoing discussions with the IIT personnel and the director and dean regarding the same. So concluding that CAMS India, as I mentioned earlier, is bringing a huge amount of opportunities to India, and it being the first setup in the entire northeastern hemisphere, it will provide because of that, this kind of research is happening for the first time in India. So most of us are not introduced to this kind of research, and it's going to provide a huge amount of opportunities. And having a first setup in northeastern hemisphere, it will provide a new insights on meteor showers, because we will get more and more new data, and because of that we may discover another new meteor shower, and from there we can get the directions of other comets and asteroids, and how their orbits are, and all these stuff can be calculated using these data. So, and the another thing is that patching the gap that CAMS has, because excluding northeastern hemisphere, which is India, and then southern Asia, Eastern Asia, and then Russia, China, these countries, excluding that, everywhere there is at least one network. And because of that, only this part of is dark. So CAMS India will patch this gap. CAMS says. So this is an image of the website of CAMS, where the all the data is made available public. So and here is a website for that, and you can also go check out how the data is available. Like for example, this Gemini's meteor shower, how the orbit of meteor shower, how the orbit of the meteor shower is, and etc. stuff can be observed in the portal. And I want to thank all these people who have helped me throughout this process to get the CAMS India setup ready. And here are all the references I have used for this today's talk. So thank you very much. I want to thank Sci-ROI for giving me a opportunity to talk here. I want to thank all the audience for listening to me, and thank you very much.